All right, block one. I don't think this is going to be perfect, but we're going to make the most of it. This is how I had to do things in the spring. So hopefully the sub got figured out how to post this on the main screen and we'll kind of make the most of the day. You guys have went through your test. Hopefully we got all that figured out. If we have any questions, I'll be back Thursday and I'll actually be there the rest of the day, Wednesday, which is tomorrow. Um, so you should have picked up two new things from the front of the room. One of them is your new packet, which is chemical bonding. Okay, that's going to be our final unit before the semester ends. And then you should have gotten a blue periodic table. So why don't you guys take a second? The sub can pause this video, but why don't you go look at that blue periodic table? I think I left the title of it on, but make sure your name gets on it and spend 13 or 15 seconds talking with each other. What is that periodic table? And what's the key giveaway? And it is something that you'll be able to use a lot. So take 30 seconds, go talk about it with each other, and which element is the key giveaway for what it is. So go look at that. Pause the video right now. All right, so unpause it. Hopefully you guys all looked at that. Hopefully you had some good discussion. Hopefully you all noticed that fluorine had a value of 4.0, and you might have noticed the title, but that is a table of electronegativities. That's that whole idea from our current chapter, trends we just tested over, and how hard things will pull on electrons. And if you look at all the halogens and all the things like noble gases, we know that those are going to pull harder on electrons. So there's a few weird things in there that we can talk about tomorrow. But I just wanted to get you started on the day. We're still going to make use of the day because we do have to get through this chapter. This will be your final exam, is your test over bonding. So if you look on the cover, everyone please get out your cover. If we need to pause the video for a second, do that. But if you go look, when we go look at chemical bonding on the cover, we're going to define it. We're going to talk about why it forms. We're going to talk about different types of bonds. We will end up doing a little lab on Thursday or Friday where you guys explore electricity and how bonding has to do with that. We'll keep talking about the octet rule. We'll talk about something called Lewis structures, and we'll start to draw some of these molecules. So to get started here, why don't you guys turn, I believe it's going to be page 3. I'm going to zoom in on my screen here. So I'm going to zoom in. So I left the second page blank, but on page 3 at the very, very top, it's the first thing that we'll start with, and that's this whole idea of what chemical bonds are. So if the sub needs to pause it, she can, but your sheet has 3 blanks right here. So if we go look at what we're talking about here, and I'm trying to talk slow since I'm on the video, what we're talking about here is that chemical bonds are forces that hold atoms together. We know all year we've been talking about if you have a bond, it's with you and your friend at least. There's at least 2 things there. If you remember, our first chapter is going to come back into play now. Our first chapter was all about naming chemical compounds, which is when there's multiple things bonding together. Well, now we're going to go as a class and talk about those bonds. So I'm going to add a few notes as you go here. If you haven't already kind of scribbled these down, make sure you do. But the 3 chemical bonds we will study in our class, the first one's going to be called ionic bonds. And you can see I'm going to make this blue here. Ionic bonds clearly are things that have an ion. So we know that this is going to be, I'm going to write in blue, this is going to be a cation plus an anion. That's that idea of something wanting to lose and something wanting to gain. The thing I've talked about all year with this is the idea of the hippo and the bird. The hippo wants to get the bugs eaten out of its mouth and the bird wants to get food. So just like a cation wants to lose and an anion wants to gain, that's how those things are coming together. Now remember, the thing that wants to become a cation usually is a, you got it, nice job Jared, I'm sure you got it. The thing that wants to become a cation is a metal. And everybody else, let's pause really quick. Pause the video. What would an anion want to be? Very good. I heard Hunter say non-metal. I'm just assuming. I know Hunter actually would, but that already starts to show you. When we look at ionic bonds, that's going to be between a metal and a non-metal. Okay, and we've already talked about that a lot. So let's keep going here. We've talked about covalent bonds just very, very briefly. What do you guys, pause the video after this question, but what do you guys remember about covalent compounds and how we named them? So why don't you take 10 seconds, 30 seconds with a partner, Go back and get your flow chart out if you want, but how did we name covalent compounds? I'm going to pause my video too. If you guys remember, when we did covalent compounds in our first chapter, we had to use Greek prefixes because it could have been CO, it could have been CO2, it could have been C2O3. So we had to say carbon dioxide or dinitrogen trioxide. But the main thing here is that that always took place when there was two nonmetals. They were both right of the staircase. And the reason why it was so weird was because they were sharing their electrons to get a full octet. They were sharing their electrons to get a full octet. Whereas over here, something was losing and something was gaining. So you guys can already start to see, we've already learned how to name these, so it's really going to make things easier as we go. But what we're going to dig into more is how do these bonds form? We already know how to name them. And what's great is you guys already know a little bit about ionization energy and things like that, which will lead into bonding itself and why certain things will come together. Last but not least, we will talk about metallic bonds, and that's just a very, very simple, for our class's sake, that's when a metal and a metal come together. And that obviously is going to be a little bit weird, but what we end up calling that is an alloy. And we'll talk about this more. The transition metals we know are kind of weird, but why don't we take a second? Henry, why don't you turn and tell the class? I know, Henry, you're there. You're doing a great job. Henry, why don't you turn and tell the class about stainless steel and why we use it in a lot of our cars instead of just plain old iron. So Henry, go ahead and pause the video, please, if you would, substitute teacher. And Henry, tell the class what an alloy is, or stainless steel at least. So if I had to guess, Henry probably froze a little bit. He might not know what an alloy is, but I do bet that Henry knows what stainless steel is and that it's not really an element. So if I were to ask Henry, why don't we use iron in cars anymore? Henry probably knows that iron rusts really, really quickly. Now, if I take iron and I take some zirconium and I take some zinc and I mix them all together, all of a sudden that metal doesn't rust so much. So what we do a lot of times with our furniture and our appliances and things in our house is that we mix metals together. We melt it at a really high temperature and they come together to form different types of alloys. Like bronze is another example. There's no such element as bronze. We make bronze by mixing two different things. That, everybody, is a metallic bond. So those are our three types. We've already talked about them a lot. I don't want to make this first video too long. So right now, before we go any further here, because now you guys are going to kind of do some stuff on your own, why don't you guys review with the person next to you the three types of bonds, and when you're reviewing that, talk about what type of elements form them and what are they doing to become stable. And then when you're done with that, I give the sub permission for you guys to take a 90-second break and go get a drink. So review the three types, put your phone away, Alex, and actually review this, and then you guys can take a break. Go ahead and pause it and get that done. All right, well that everyone's back from their break, hopefully you guys are refreshed. Hopefully, as I watch this right now, it's the first quarter of the girls' basketball game when I'm recording this part. I'll record the other part later tomorrow morning probably. But we've now introduced the types of bonds we're going to have in this chapter, and then you're going to do something a little different. And I expect us, we're upperclassmen, I expect us to kind of cooperate here. We're going to make the most of it, but what we're going to do really quick as a group is we're going to define what a chemical bond is, and then I know we don't use it very often, but I actually want you to go get your textbooks, okay? I think it's important you guys learn how to kind of be independent. So remember, we know that bonds are going to form to make things more stable, all right? So what I'm going to pull up on my screen right now is chapter 6 of the textbook, okay? So these are over on the far door, or on the far wall. You guys can go snag them. But if you go grab it and look at chapter 6, don't go grab it yet, just give me a second. What chapter 6 is going to do is break down the chapter into different parts. So if you go look at the first part, it's just a simple, in section 1, it's a simple introduction to bonding, all right? And I wanted to hit this as a class really quick because on your packet, you need to define what a chemical bond is. And it just so happens that if we zoom in on this bad boy here, we can all go look at what a chemical bond is. So let's go write this together. Sub, I think Mrs. Becker was who took my job. I couldn't quite remember. If you could, why don't you pause this while it's up on the screen so that other kids can write it down. Pause this video while it's up on the screen so the kids can go write it down. Now, we will dig way more into this together, but a chemical bond is a mutual. Again, mutual meaning both things want it to happen. Mutual means both things want it to happen. Electrical attraction. Now, why do we use the word electrical? We're not talking about wiring. What we're talking about is electrons, and especially we're talking about those valence electrons and how everything wants to look like a noble gas. So, we know that those electrons are attracted to the nucleus of other things. So tomorrow we'll talk about that goofy little graph at the bottom of your notes, this guy. This is probably more of an in-person talk, but the electrons of one thing start to get attracted to the nucleus of another atom, and that's how bonds come together. And then we know that that's a bond that holds those things together, and it all comes down to stability. So just building on a few other things here, you're going to go read right now. And I want you to get in partners. I know we don't do this often, but I actually want you to put your phones away and I want you to read Chapter 6, Section 1 about bonding. You can take any notes that you want to. Obviously, I will hit those things with you, but you're going to start reading about more stable arrangements and why bonding happens. You're going to look about things with the periodic law that we just learned about. It's going to start to differentiate between ionic bonding and covalent bonding. You're going to start to read the difference between the two. Okay, what it's even going to start to do is look at, and this is going to be hard for you guys, but I promise you can do it. What you're going to start to do is look at the electronegativity difference between things, and you'll need your blue periodic tables to do this, okay? So for right now, what I'm going to say is that I want you to go and I want you to read chapter 6.1 out loud with another person in class, all right? If you get looking, there's going to be lots of good stuff. You don't need to do the practice problems yet, but I want you to go grab a textbook. You're going to open it up to chapter 6, section 1, and you're going to take turns reading, like I think we called it popcorn reading when you were little. But you're going to be focused, you're going to do your best, and then we're going to come back and look at this idea of covalent bonds and maybe even a little bit more while you're on your own today. So go get reading. I'm going to end this video for right now. So go get your books and get reading.